So the rest, I think you'll admit as they come. Right, thank you. Welcome to our mentorship program. My name is Patrick Mboya, a teacher of mathematics at Maseno School. And I believe I have got some of my students also in this platform. This is okay. Our mentorship program is going to run for 2 hours, but we are going to take 1 hour, 40 minutes presentation, and then about 15 minutes or so, I'll be taking questions from you and responding to them. Our first session will be mathematics paper 1. That's going to run to about 1:30. And then the second session will begin at 2 for mathematics paper 2, which will be facilitated by another senior examiner. For those that have not interacted with me, it's important to let you know that I am a senior examiner of mathematics paper 1, a teacher, and also a writer of mathematics books, that is the Smart Maths. I want straight away to go to the subject matter, that is mathematics paper 1, the scope of the paper, what mathematics paper 1 entails, the common mistakes that we normally see the candidates are committing and costing them, and how we can maximize the marks or the scores in the examination that is mathematics paper 1. Now, when you ask many students, what do you understand by mathematics paper 1? Many students will say, it is simply Form 1 and Form 2 work. And that is a misleading response. Paper 1 is not simply paper 1, Form 1 and Form 2 work, but I can say it is largely application of Form 1 and Form 2 works. Largely application of Form 1 and Form 2 works. So in this presentation, we are going to look at the scope of 121/1. Under the scope, we will mention the key areas of focus, or the specific areas of focus when it comes to 121/1. And we are looking at the specific areas of focus in line with the KCSE 2024. So what are the specific areas of focus? So that as we prepare, what are the areas we need to lay much emphasis on? A good candidate, a candidate scoring averagely 40 to 50% in paper 1, if given the tips required, can boost the scores immediately by not less than 20 marks. Most of the candidates lose up to 20 marks because of the tips that they are not, exposed to early enough as they prepare. So under the scope, we'll start by saying section 1, 50 marks, is comprising of Form 1, 25 marks, then Form 2, also 25 marks. But sometimes Form 2 covers only 22 marks, then the other 3 marks are drawn from Form 3 and from Form 4. So it means that if a candidate is well-grounded in Form 1 and Form 2, you can score a minimum of 47 marks in Section 1 alone. Minimum of 47 in Section 1 alone. Now, we move on to section 2. Also 50 marks. And these 50 marks are from 8 questions from which you are supposed to select 5. Then the 5 are basically 1 from 1, 4 from 2, then from 3 and 4, 3. That one comes to 8 questions obtained from section 2, and from which you are supposed to answer only 5. It also implies that without even covering from 3 and from 4, you can still answer the 5 questions. However, the 3 questions of from 3 and from 4 are normally questions that are very easy to tackle, and therefore we'll look through into all those areas. Allow me, therefore, to take you through the scope of paper 1 and look at the 10 key areas of Form 1. The 10 key areas of Form 1. In Form 1, what are the areas that you must focus on, and what are the key issues that you must also lay emphasis on as you handle Form 1 work? Number 1 is the number system, number work system, numbers. I want to let you understand or let you know that when you talk about numbers, we are referring to, do you know how to classify numbers? For example, do you know what we mean by prime numbers? Numbers that are greater than 1, whole numbers greater than 1, and I've got only 2 divisors, the number itself and 1. For example, 2, 3, 5, 7, 11, and so on. We talk about prime composite numbers. Now, these are numbers which are not prime. They are not prime. Whole numbers, more than 1, they are not prime. And that one means they can be expressed as products of their prime factors. For example, if you skip 2 and 3, which are prime numbers, 4 is a composite number because 4 can be expressed as 2 by 2 in terms of its prime factors. 5 is a prime number. 6 is a composite number, 2 by 3. 2 and 3, the composites, are prime numbers. 7 is a prime number. 8 is composite, 2 by 2 by 2. 9 is composite, 3 by 3. 10 is composite, 2 by 5. 11 is prime. 12 is composite, 2 by 2 by 3. 13 is prime. 14 is composite, 2 by 7. In other words, a composite number can be expressed as a product of its prime factors. We look at square numbers. Square numbers are the whole numbers that have perfect square roots. For example, 1 is a square number. That is 1 times 1. 4 is a square number, 2 by 2. 9 is a square number, 3 by 3, and so on. Even numbers, odd numbers, integers. So you must understand the full array of numbers. And as you understand the number classification, you also look into the evaluation. Evaluation involving integers, where you are told, without using a calculator, evaluate. And if the answer if it leads you to an answer which is an improper fraction, you must express that your answer in terms of, in its mixed number form. For example, if your answer is 10 over 3, you have to go ahead and say, this is 3 and a third. And note that I don't expect a candidate to give me the answer 0.33. Even if it is in 4 significant figures, this one, the accuracy mark will be lost and you'll get a 0. So you simplify it and give it in its mixed number form, unless a specific instruction is provided. For example, you are told, give your answer correct to 3 decimal places or 4 significant figures. In that case, this one will work. But if you're just told evaluate, giving your answer in its simplest form, and the answer is 10 over 3, it goes ahead to 3 and a part. So you must look into evaluation, those under numbers. Then also under numbers, you must look into significant figures, decimal places, total values, place values. Those are also components of numbers that you must look into. Significant figures, decimal places, total values, place values. Normally, these are called accuracy remarks. For example, you are told, evaluate, giving your answer correct to 2 decimal places. If the answer, for example, has been 10.375, you'll get A0. But if you go ahead and say this is 10.38, correct 2 decimal places, now you'll get A1. So these parts, like significant figures, decimal places, total values, place values, are components of the number system that also carry in them accuracy part of equation. Hope we are okay up to that point. Arnold Otieno, Fred Sewe, and all that, Kanaga, hope you are okay with that. You can just show by raise of hand if you're getting me. If you're getting me, you can confirm by show of hands. Okay, thank you. Thank you. We continue. Apart from the number system, we look at the second component. Other than the number system, we look at the second component, and the second component I will call fractions and decimals. Fractions and decimals. Fractions and decimals. Now, when we talk about fractions and decimals, we are looking at one evaluation. Here, you must learn to simplify your final answer. For example, if you are asked without using a calculator, evaluate. Without using a calculator, evaluate. And the question involves fractions. The evidence that a calculator has not been used will be the LCM of the denominators. For example, you cannot add 1 over 3 directly to 2 over 5 without showing us the LCM of 3 and 5. So you must show the evidence that a calculator has not been used. We also look at conversion. For example, there was recently candidates were asked to convert 5.555 Africa Ring into fraction. Many candidates knew the answer offhand, that the answer is 5 and 5 over 9, but they could not therefore score the 3 marks because there were marks allocated for methods. So in this case, in conversion, you must also know the correct way of converting decimals into fractions. We also look into the application. Word problems involving fractions and decimals. Word problems involving fractions and decimals. You must also look into them as part of fractions and decimals. Remember, we are talking about broad categories. Broad categories. This is numbers is number 1. This is fraction and decimals number 2. Number 3, we talk about rates, ratios, and proportions. As you prepare for an exam and you are looking into rates, ratios, and proportion, practice with application questions. Go to word problems leading to rates, ratios, and proportion. And also a key point to remember is that in ratios, a ratio must be in its simplest form. For example, if you are getting a ratio between 1.2 meters and 80 centimeters, this is not appropriate. You cannot have a ratio given in that form because of 2 reasons. One reason, the units are different. Ratios only exist if the units are the same. Another reason, they are not simplified. So it means we are talking about 120 centimeters to 80 centimeters, which simplifies to 3 to 2. Now, that is now a ratio. You have to express them in the same unit, and you have to simplify them down to the lowest level. But also, it is important for you to respond to the need of the question. If the examiner, for example, says, give your answer in the form 1 to n, then it means this side must be 1 and that side must be n. So divided by 3, which means you're talking about 1 to 2 over 3. This is in line with the requirement of the question. Give your answer in the form n to 1. N to 1, which means this side must be 1. So divided by 2, therefore 3 over 2 to 1, which is 1.5 ratio 1. N to 1. You see? So that is in line with the requirement of the question. So all the time, you must also get into what the question requires, the form in which the answer is required. Number 3, angles. No, number 3, number 4. Number 4, angles and plane figures. Angles and plane figures. It begins with your understanding of a triangle, the types of triangles, the right angle triangles, isosceles triangles, equilateral triangles, scalenes, and so on and so forth. From triangles, it goes to quadrilaterals, four-sided figures, from rhombus, parallelogram, square, rectangle, trapezium, kite, arrowhead, and so on and so forth. From the quadrilaterals, it advances to polygons. Polygons. Poly, many, poly, many. So polygons, many-sided plane figures. So we talk about polygons. We begin with 5-sided plane figure, pentagon, 6-sided plane figure, hexagon, 7-sided plane figure, 8, 9, 10, and so on and so forth. But in all those cases, we are concerned with the polygon formulas. And polygon formulas are 3. When you talk about polygon formulas, we say the polygon formulas are 3. What are they? What are these 3 polygon formulas? The 3 polygon formulas are as follows. If you take any regular polygon, regular to mean all sides equal, of course, all interior angles equal. If you take any regular polygon, assuming that this polygon is regular, the 6-sided polygon, all the 6 sides are equal in length, all the interior angles are equal. If you take that case, then we call this angle interior and the other angle exterior. Interior angle plus exterior angle gives you an 80 degrees. That's a polygon formula. If you take 360 and you divide by 1 exterior angle, you get the number of sides. You get the number of sides. If you get the number of sides, subtract 2, you get the number of triangles in this polygon when it is subdivided from 1 vertex. That is 1, 2, 3, 4 triangles. But the sides 1, 2, 3, 4 triangles. But the sides are 6. So you can see 6 sides minus 2 will give you 4 triangles. And we also know that the interior angles of 1 triangle add up to 180 degrees. So if you multiply this by 180, you get what we call the sum of interior angles of a polygon. This formula is applicable to both regular and irregular polygons. Both regular and irregular polygons. So you have to understand how these formulas operate. I want to involve you a little for 1 minute by posing a question to you. You can note it down. Note it down. Note it down. The sum of interior angles of a regular polygon is 1,980 degrees. The sum of interior angles of a regular polygon is 1,980 degrees. The sum of interior angles of a regular polygon is 1,980 degrees. Calculate the size of each exterior angle of the polygon. I repeat, the sum of the interior angles of a regular polygon is 1,980 degrees. Calculate the size of each exterior angle of the polygon. Calculate the size of each exterior angle of the polygon. If you have got your answer, you may post it. You may just post it. Or you may unmute and just say your answer. We have 1 minute for that. Anyone with a response? Yes, Darrell? Darrell? It's not getting unmuted. This one. Oh. Unmute and say it, please.
13.
13. Otieno? Basil? Unmute and say it.
27.69 degrees.
27.69, that's 13. Any other person? Yes, Bradley, unmute and say it.
27.69.
We have Whitney. Unmute and say it, please. Yes, Whitney. Martin. Niklim. Okay.
27.69.
All right. Enough of the responses for now. Let us look at it. The first presenter, the first response was 13, and that 13 was actually the number of sides. So the first candidate got the number of sides correctly. By applying the formula, 180 into n minus 2, giving us 1980, which means that n minus 2 is 11, so that n is equal to 13. But we don't stop there. That one gives us the number of sides. The number of sides. The question asks, for the size of each exterior angle. So for the exterior angle, now we go down to get now the exterior angle, and we say exterior angle is 360 over the number of sides. And I chose this question intentionally. 360 over the number of sides. Now that answer, you realize that it is non-terminating or it is recurring. If it is recurring, we don't expect you to give your answer in its approximate form, even if it is 4 significant figures. Instead, we expect your answer to be 27 and 9/13 degrees. That is the exact size of the exterior angle. Because if you multiply 27.69 by 13, you don't get 360. You'll get something close to it, but not 360. So where the answer is not terminating, it's recurring. Give it in its exact form, and the exact form is a mixed number format. Are we communicating on that, up to that point? Thank you. Good. We move on to number 5. After looking at angles and plane figures, and we are focusing on the polygons, we move to the 5th level out of the 10, and the 5th level, we call it commercial arithmetic. Commercial arithmetic 1. That is the 5th band of KCSE setting. The 5th band is commercial arithmetic 1, where our focus is on 4 areas. It is on forex or foreign exchange. It is also on commission. It is also on discounts. And it is also on profit and loss. So as you work out commercial arithmetic 1, you are reminded that those are the 4 key areas. For a candidate, don't walk into an exam room without looking into those 4 key areas. And whenever you are talking of foreign exchange, pay attention to the accuracy part of the question. That is, for example, you are asked, give your answer to the nearest Kenya shilling. Give your answer to the nearest rand. For example, KCC 2017. Give your answer to the nearest rand. You are supposed to round off just in the normal way. If your answer, for example, is 6,311.75 rands, don't say this is going to be 6,311. You truncate, and your argument is the bank will make a loss if you round off in the normal way. No, your work is simple to round off to the nearest rand, and therefore you say this is approximately 6,312 rands, correct, to the nearest rand. So we must look into those areas under commercial arithmetic number 5. Number 6. Number 6, LCM and GCD. LCM and GCD. We are focused on application. Application. The focus is on application. And because it is a word problem, and for your information, it has never missed. I remember 2018, it was GCD. 3 wires of length, 30 meters, 36 meters, and 84 meters are cut into equal pieces. Calculate the least number of pieces obtained. Many candidates rushed into LCM because they saw the word least, which was incorrect. When the wires are cut, it means we are subdividing. We are talking about GCD. So the candidates were expected to get the GCD of 30, 36, and of course 84, which was 6. So the 6 was the GCD, or the length of one piece. So the number of pieces would be 30 over 6 plus 36 over 6 plus 84 over 6, giving you 25 pieces. That was KCC of 2018. So you have to understand the equation, break it down, and solve it. In 2019, it was LCM, simple one. And I'm seeing the hands of Terry. Terry, unmute and say your concern, please.
Could you please repeat the question from the KCSE?
About the LCM and GCD?
Yes, please.
Okay, thank you. What I was saying that if you look at the KCC of 2018, and I think I have it here, I can just refer to it quickly. But the equation was 3 wires of length. Let me just get it verbatim, the way it is. 2018. The lengths of 3 wires were 30 meters, 36 meters, and 84 meters. Pieces of wire of equal length were cut from the 3 wires. Calculate the least number of pieces obtained. You can get that one from KCC 2018. Now, because they are cut, what comes into your mind is the GCD. They are cut into equal pieces, GCD. So we were expecting the candidates to get the GCD of 30, 36, and 84, which was 6. So it means one piece would be 6 meters. Now, when you're looking for the least number obtained, the least number obtained is the length of the wire divided by the largest possible length of one piece. So we'll talk about 30 over 6 plus 36 over 6 plus 84 over 6, which is 6 plus 5 plus 14, and that is 25. So that is how we expect a candidate to respond and score all the 4 marks, LCM and GCD. In the year 2020, again, application of GCD resurfaced. This time around, the candidates were given a question like, a rectangular room, the dimensions are 4.2 meters by 5.4 meters. And the room is to be tiled using square tiles. It should be carpeted using square tiles. What does it mean? It means that the floor is subdivided. And then the examiner asked for the least number of tiles that will be used. So we would first of all get the largest dimension of one tile, of one square tile, which means we expected the candidates to find the GCD of 4.2 and 5.4. 2 challenges. One challenge was knowing that the GCD was required. The second challenge was getting the GCD of decimal numbers. But we expected the candidates to simply remove the decimals by multiplying by 10 by 10, by 10 by 10. Then you get the GCD of 42 and 54, which is 6. Then divide it back by 10, you get to be 0.6. So in that case, the GCD was 0.6 meters. Now, after getting the GCD, or the length of one square tile, then the number of tiles would be 4.2 over 0.6 times 5.4 over 0.6, which is 7 by, of course, 9, and that is 63 tiles. You can see application of LCM and GCD. I want the candidates, whether you're in Form 3 or in Form 4, to look into different scenarios or different questions from KCSE spanning 2018 to 2023 and solve the questions involving LCM and GCD. That was number 6. Number 7. Number 7. Number 7, linear equations. Linear equations. When we talk about linear equations in context of the broad category of KCSE Form 1 work, then we are referring to forming and solving equations in one unknown and in two unknowns. In one unknown, that is where you are finding equations like a father is, let's say, 4 times as old as a son. In maybe 6 years' time, the sum of the ages will be such a figure. How old was the father when the son was born? You know, those are cases where you are forming a linear equation in one unknown and solving it. In two unknowns, we are referring to simultaneous equations. And for preparation of KCSE, we are talking about methods such as elimination, substitution, graphical, and matrix. Those are the methods of solving simultaneous equations that we will expect a candidate to be conversant with. The methods of solving the linear equations in two unknowns. Number 8, time. Time. A very small part, very small subtopic, but in this subtopic, it's a very important component of KCSE syllabus. Under time, we look into the addition and subtraction of time. Addition and subtraction of time. We are also looking at 12 and 24-hour system. We are also looking at time gain, and time loss. Time gain and time loss. We look at the addition and subtraction of time. We are looking at the 12-hour clock system and 24-hour clock system. We are looking at time gain and time loss. The question of time is day-to-day application. Nothing is hidden. For example, you are told that in a 4 by 100, you know, 4 by 100 means each athlete takes 100 meters. In a 4 by 100 meters race, each athlete, maybe one athlete takes 10 seconds. All right. Another athlete maybe takes given time. Another athlete takes another time. The fourth one takes another time. Then you are told they began the race at 10:45 a.m. What does it mean? The time in hours, minutes, and seconds. So the seconds will be added and will be affecting the second part of the time. If more than 60, affecting the minute part. Basic addition and subtraction of time. 12-hour clock system, 24-hour clock system is application. You are told a bus left Kisumu on Sunday at 5:45 p.m. for Mombasa. The journey took 15 hours, 24 minutes. At what time did the bus arrive? You don't just start adding this to that. No, you have to convert for us this time into 24-hour clock system before you add. So we expect the candidate to be talking about Sunday. If you add 12, 1745 hours. We are now adding 15 hours, 24 minutes. Look at that. Look at a very basic addition. The basic addition is 9, 6, 2, 3. There is not such a time. we have to go to the minute part and take an hour. 9:33. There is no such a time. It goes beyond 24. What does it mean? We are into Monday. So subtract 24 for a day. 9, 0, that is also 9, 0. Therefore, the arrival time is Monday, 0909 hours, or simply Monday, 9:09 a.m. You have to be systematic in your presentation of the response. Don't rush. Be systematic. Know what to do with the units that we have under time. Addition and subtraction of time, you can refer to KCSE of 2013. KCSE of 2013. To look into an example where we are talking about addition and subtraction of time. We move on to number 9, measurement. Measurement, that is areas, volumes, of course, mass and density will come into this. But under measurement, put a lot of emphasis on logic. It must make sense. The measurement must make sense. If, for example, you are told that cylindrical tins are arranged in a carton, in a rectangular carton, then you should also know that what determines the number of tins that will be arranged in this carton will be the diameter of the tin and the height of the tin. That is what will determine the number of tins that will be arranged height-wise or vertically in this carton. So we look into the logic. If, for example, you are calculating the number of trips by a pickup, maybe the pickup is carrying goods from point A to point B, and you realize the number of trips are 4.275 trips. You cannot say this is 4 trips. For if you say so, it means certain part of the luggage will not be ferried. So you have to round up logic that this is approximately 5 trips. It has to come back for the little part of the luggage that is 0.275. So part of measurement will be in the logic. And number 10, Form 1. Number 10, Form 1, we talk about geometry. When we talk about geometry, we are referring to basic construction. Dear candidates, basic construction involves constructing basic angles, 60 and 90, bisecting them and getting composite angles such as 75 degrees, 52.5, 67.5, and so on. We also talk about division of a line proportionately using a ruler, a pair of compasses, and set squares. We also talk about dropping a perpendicular from a point to a given line. We also talk about measurement scales, measuring a given angle, measuring a given length. Then we also talk about constructing parallel lines. I want to warn you that where you are having a doubt, don't con the examiner. For example, you are constructing 75 degrees. And 75 degrees, we know is supposed to be, you can talk about 45 and you can talk about 30. So it means if I want 75, I may do 90. I may do 90. This side, I may do 60. So what I'm remaining here with is 30. If I bisect this 30, I will have 15. 15 and 60 will give me 75. In other words, there is no way out I can make this 75 without showing the examiner how some 90 was coming about and how some 60 was coming about. Those are the basic angles. So we have to look into that. The examiner will look into the construction arcs, how you are coming up with 60, how you're coming up with 90, and so on and so forth. So don't count the examiner. Like sometimes we see a candidate is taking a pair of compasses, a protractor putting here. You can see he's marking 75, taking a ruler and drawing a line. Then the candidate is doing some robbery, and saying this is 75. No. Show the skill of construction. Don't measure and then you try to rob it. It cannot work. You will always be discovered. After the basic construction, we look into scale drawing. Scale drawing, we are focusing on one main thing. This main thing is parallel north line. Parallel north line. The north lines must be parallel. The good thing with scale drawing is that you are allowed also to do what? To measure the angles. For example, if you are asked, you are told point B is on a bearing of, say, 70 degrees from point A. All right. So I want to have my point A here. You will see what I'm doing. This is my point A. But I must begin with a vertical line, north line. I have done my horizontal line, which I've just used a ruler to draw. Then I will take my protractor, place it here, get where 90 is. Then I obtain my north line. From the north line, I can now measure 70 degrees clockwise from the north. Let's say point B is here. How do I draw a north line at that point? Many of the candidates, you know what they do? Many of the candidates use a set square to draw a parallel line to this. Instead, I would want you to measure the angle. How do I measure the angle? If this is 70, and we have learned from the angles and plane figures that the alternate angle, if it is also measured to be 70, we will get a line parallel. So you measure 70 down here, and you get another north line. So the lines are parallel. From there, you can get C if it depends on B accurately. So scale drawing is key. And another knowledge under scale drawing is that all your construction lines in the scale drawing, all of them must be continuous. I don't want to see broken lines in your scale drawing. Let all the lines be continuous. Hope we are okay up to that point. Number 3 under geometry is what we call common solids. Common solids. Common solids has got 2 aspects. The first aspect being the net of a solid, and the second one means completion of figures. Completion of figures. Completion of figures, and then the net. What do we say about the net? And what do we say about completion of figures? I want to begin with the net. A net is accurately constructed if the dimensions of the figure are able to fit in your working space, and let's say the length of the original figure is 3 centimeters, then the same length should be the 3 centimeters on a net. In a case where the figure has got lengths drawn to scale, for example, in the original figure, the length is indicated as 30 centimeters. That one cannot fit in your working space. You have to reduce it and draw it to scale. The bottom line is the net must be accurately constructed. Number two, to note under the net, is that all the lines in a net are continuous. Why? Because we are able to see the net. The net means all the edges have been split open and we are able to view them. So all the lines in the net must be continuous. For the completion of the figure, what we have to note, two things. Number one, where there are hidden edges, you use a broken line. That's number one. Number two, you must transfer the lines and angles correctly. And of course, number three, you must label the vertices appropriately. Take a case. Take a case. You are given a figure and you are told A, B, C, of course D, E, F. You are told A, B, C, D, E, F represents A, B, C, D, E, F represents a triangular prism, incomplete figure of a triangular prism. One edge, BC, is already drawn. Complete the figure. 3 marks. The 3 marks come from number one. The 3 marks come from number one, transfer of lines and angles. How do you transfer lines and angles? Using your pair of compasses, you will stand at BC, stand there, you make it. Stand at BE, stand there, you make it, so that you can see this one will come there and this one will come here. So that this ABC is a D somewhere, E and there's an F already obtained. Vertical height, A and E drop from F, you get there. B and A come to C, get there, and you see it coming now hidden because we are not able to see that edge. So this one becomes ABC, D, E, F. So that is the figure. You ensure the angles are transferred correctly, the lines are transferred correctly, the hidden edges are shown using broken lines, and the vertices are correctly labeled. That is what will make it a complete sketch. Never use freehand in drawing the lines. Always use a straight edge of a ruler, correct ruler. So that one summarizes the Form 1 work. In Form 1 work, Section 2 will be one question, and that one question can come from either geometry, that one question can come from rates ratios, that one question can come from measurement, that one question can come from commercial arithmetic. So those are the 4 areas from which Form 1 can be set in Section 2. Be careful with Form 1 work in Section 2 because they largely test logic. So that one summarizes Form 1. We are within time. When we continue with Form 2, I will not go so deep in Form 2 for Section 1. Instead, I will preserve the depth of Form 2 for Section 2, because we have agreed that Form 2 will carry 4 questions out of the 8 questions. Form 2 are 4. In other words, Form 2 will give us about 40 marks from some 7 areas that I am going to share with you. Form 2 will be carrying 40 marks from some 7 areas that I'm going to share with you. But there are certain areas which are basically Section 1 areas. And one of them is indices. Section 1, indices, simplifying, solving, and so on and so forth. Basically, indices test your application of factors in Form 1. For example, if I tell you to find x and y when 4 raised to power x times 3 raised to power y is 216. And I say, what is x? What is y? This is indices, but it also tests on factorization. First of all, I have to ask myself, can 4 be factorized? Yes, as 2 squared. So I have this one. I'll have this one. The next question, can 216 be broken down? Can it be factorized? Yes. If I take 216 and I factorize it, I will get 2 cubed by 3 cubed. And remember, if the question is stated without using a calculator, find x and y. The examiner is looking for a point where you are breaking down to 16. You are breaking down to 16. Then you see 1, 2, 3, yo-yo. 1, 2, 3, yo-yo. You must have the evidence that a calculator was not used in that evaluation. Otherwise, no mark will be scored. So once you have this one, you can compare the powers and say from here directly, 2x is equal to 3, and therefore x is 3/2 or 1.5. Y is equal to 3. Full stop. In this scenario, the answer x is 3/2 will not be allowed. The answer must be simplified, must be given in its simplest form. The answer must be given in its simplest form. You don't say the answer is 3/2. No, 1.5. Or even 1.5, because half is a terminating decimal. It ends at 0.5. Hope we are very clear in our presentation this far. So you look at the questions of indices. And before I forget, you are a candidate. How do you prepare with the past papers? Don't just go to all the past papers in the name of preparation. No, focus on the last 5 years. Focus on the last 5 years. If we take, for example, 2020, 21, 22, 23, those are 4, plus 2019. Those are adequate for our preparation. KCSE, you look at them item by item, focus on how you are getting their answers. Where there is concern, ask questions. Ask questions. Don't just die with it cracking your head. Ask questions, consult, so that by the time you're going for the KCSE, you are comfortable with all questions in the last 5 years. Apart from indices, we can also look into, of course, logarithms. Logarithms, that is reading logs correctly, adding and subtracting logs, division of logs by 2 or multiplication of logs, and then the reading of anti-logs correctly. You look into the logarithms under those areas. The third area in Form 2 we look into is called trigonometry. Trigonometry, we are focusing into 4 areas. What are the 4 areas? Ratios, sine, cosine, tangent. Sine, cosine, tangent. For example, you are told, given that sine theta is equal to 2/3, find without using a calculator, tangent of 90 minus theta. You see, basics from SOHCAHTOA, that sine of an angle is opposite of hypotenuse. So it means from this knowledge, if you let this one be our theta, then sine theta is opposite of hypotenuse. By applying Pythagoras theorem, you can get the base. That is 9 minus 4, giving you 5. Root of it becomes the adjacent. So if this one is theta and this one is 90, from the complementary sizes here, it means this one is 90 minus theta. So tan of this angle, which is 90 minus theta, is opposite over adjacent. And you get your answer. So the application of ratios is important. Another important part in the trigonometry, is special angles. Special angles. A candidate must understand that special angles include 30, 45, 60, even 90 is a special angle. Somebody has raised a hand. Can I listen maybe for a minute? Willie? Willie?
I have a question.
Yes.
It goes like this.
Yes.
Solve the question. For cos, open the bracket. For cos, open the bracket, 4x plus 20.
4x?
Plus 20 is equals to 2 sine, open the bracket, 4x plus 20.
Thank you.
To one decimal place.
No problem.
Between.
No problem. This one falls under the ratios. It falls under the ratios because the angles inside here, we can see they're the same, right? And we know that sine theta over cos theta is tan theta. So you can see if I divide this one by cos of 4x plus 20, this are also divided by cos 4x plus 20. This one will go, and therefore it means that 4 is equal to 2 tan of 4x plus 20. Right? Again, divided by 2, then you will realize that tan of 4x plus 20 is equal to 2. From here, you can get what 4x plus 20 is by getting the tan inverse of 2 within the domain that you are given. You can see it's just the basic thing. Right? Okay, we can continue a little. But the main thing here was, once you see the angles are the same, there's a cos and there's a sine, then what must come into your mind is that sine of an angle divided by cos of the same angle is tan of the angle. Good. So special angles. Good. The special angles here, I said are 30, 45, 60, and you must know what is sine 30. These ones you must know offhand as a candidate. Sine 30 is a half. Cos 30 is square root of 3 over 2. Tan 30 is square root of 3 over 3. Go to 45. Sine 45 is square root of 2 over 2. Cos 45 is the same, square root of 2 over 2. Tan 45 is 1. Go to 60. Sine 60 is root 3 over 2. Cos 60 is a half. Tan 60 is root 3. These are items that a candidate must have at fingertips. You must have them at fingertips because they can be applied in the third area, which is called complementary angles. Complementary angles, where you are told if sine this is equal to cos that, find that angle. Hence, find the tan of this angle, the exact value of it. No, that is where we are applying the complementary angles. Special angles are applied here. Then, of course, we go to elevation and depression. Elevation and depression angles. So we need to look into those areas. We need to look into these areas under trigonometry. Still in Form 2, allow me to talk about one area under Form 2, and that is linear inequalities. Linear inequalities. Solving linear inequalities, expressing your answer in a number line. And I want to just talk about a scale. The scale here is the scale for drawing number line. You have solved the inequality and you have found your final answer is -2 less than or equal to x less than 3. Number line is a simple thing. You will take your ruler, you will draw a straight line, put arrows on both ends, subdivide it equally, -2, -1, 0, 1, 2, 3, or even up to 5. it is beginning from -2, less than or equal to, which means I shade it. It is ending at 3. I circle, but I don't shade because it's not part of it. And the line segment between -2 and 3, you take your ruler and you make it bold. You just make that line part bold. You make the line part bold using your ruler. That is the number line. That is the number line. The integral values of x in this case are -2, -1, 0, 1, and 2, separated by the commas. There was a time where candidates were given a question like this and they were asked to list the integral values, which were 1, 2, and 3. Some candidates wrote that way. That is wrong because this is 123. The integral values had to be separated using the commas to show that is 1, 2, 3. Those are the integral values. So you look into the number line system. What about a case where the answers are -2 and a third, less than or equal to x, less than 3 and a quarter? A case has come. We have such a case. We want to draw a number line to represent that. A number line to represent that. We are having a straight line with arrows on both ends. Let's say -3, -2, -1, 0, 1, 2, 3, 4, 5, even 6. The arrows must be in both ends. The line must be straight. The subdivisions must be regular. They must be regular. So once I have this, I will estimate where -2 and a third is. -2 and a third is approximately here, circled and shaded. But because the point in which it lies is not an integral point, it's not an integer, I will mention it up there, -2 and a third. The same, 3 and a quarter is some portion after 3, circled and not shaded. And because the point again is a mere estimate on my number line, I will indicate 3 and a quarter. Then I make that line segment bold. What about the integral values? You pick the integers within that domain, and the integers are -2, -1, 0, 1, 2, 3. Those are the integers falling within. These ones are not integers, they are mixed numbers. So you have to look into that. There are other areas of Form 2, such as enlargement and similarity. There are other areas such as, symmetry and all that. Can I get a question from Willie Jacqueline? Unmute, please, and ask.
Chair, back to the trigonometry ratio.
Yes.
I would like you to explain for me how to go about this question.
How to go?
About this question.
Mm-hmm.
Tan 240 over sine 60.
Tan 240?
Over sine 60 minus cos 135.
Tan
Without
240? Tan 240?
Over sine 60 minus cos 135.
Everything minus?
Yeah. No. The whole tan 240 over.
Oh, this is minus?
Yeah.
Like that?
Yes. Without using a calculator, simplify.
Of course, I would not give you this kind of a question for paper 1, but if it comes, these are special angles. You look into 240. In which quadrant is 240 lying? In which quadrant is 240 lying? Remember, we have got the first, second, third, and fourth, right? All students take chemistry. Okay. In the first quadrant, we are talking about 0 to 90, 90 to 180, 180 to to 70. So this is the third quadrant. All students take. So in the third quadrant, tan is positive. So we are talking about tan of 240 minus 180. The component of that. This is just sin 60. Cos 135 is in the second quadrant. 180 minus 135. And in the second quadrant, cos is negative. So minus, it becomes minus. So we are talking about tan of 60 over sin 60 plus, because the cos of 135 is negative. So plus cos of 45. So from there, I told you must have the special angles at fingertips. We talk about tan 60 root 3. Sin 60 root 3 over 2. Cos 45 root 2 over 2. All right? Hello? So from that moment, you can move ahead and say this is the same as 2 root 3 over root 3 plus root 2, taking you to a topic in Form 3 called SADS. So in paper 1, I would not give you such a task because it would lead you into SADS Form 3 work, paper 2 work. So I would not go much into it. So allow me, therefore, to lead you into Form 2, Section 2. I have 35 minutes, and we have to cover it in good time. Within the 35 minutes, we want to cover these elements. I just give you the highlights of Form 2. When you are preparing for Paper 1, Section 2, from Form 2, what are the areas you are supposed to prepare on? There are 7. And those areas which are 7, 4 of them will be in the exam. So how do you prepare for Form 2? Let us list the following topics. Let us list down the following topics. Let us list down the following topics. Number 1, gradient and equation of a line. Gradient and equation of a straight line. That is a very important component of Form 2, Section 2. And under gradient and equation of a straight line, a candidate must know how to get equation of a straight line given 2 points. Equation of a line given 2 points. You must know equation of a line given 2 points. Equation of a line given 2 points. You must also know the relationship between parallel and perpendicular lines. How do they relate in terms of their gradients? You must also know what we call the intercepts of a line. X-intercept. At x-intercept, y is 0. At y-intercept, x is 0. These are a must know under the gradient and equation of a line. And the fourth area of concern is point of intersection. The point of intersection. And as you look into all this, pay attention to midpoints and also the form of equation. You pay attention to midpoints and also to the form of equation. You pay attention to the midpoints and also to the form of equations. That is what is involved in the gradient and equation of a straight line. The point of reference for practice is KCSE from 2015 onwards. Just the equations on gradient and equation of a straight line for 10 marks. You pick questions from 2015 coming forward and you solve them. You'll realize that each question entails the 4 key areas. Number 2, measurement. I told you there are 7. Number 2, measurements. Number two, measurements. Number two, measurements. When you talk about measurements in reference to Form 2 work, we are talking about volume and surface area of solids which have got conical components. Conical components. Components. These solids include shapes such as a bucket, a glass, shapes such as a conical flask, shapes such as a funnel. These are shapes that have got components which are conical. You can have a cone, a cylinder, a hemisphere, all in one. And as you look into this, you must also understand the basics of getting the volume and surface area of frustums. Volume and surface area of frustums. Volume and surface area of frustums. I want each one of you to draw. Draw a bucket. The radius up to a small r. The radius up here, equal capital R. The vertical height of this frustum, equal H. The slanting height of this frustum, the slanting height, equal L. Let us draw that. I'm giving you 1 minute to do that type of drawing. Just draw it. Yeah. I hope it has been drawn. I hope it has been drawn. That is, we have drawn a bucket or a glass. It can be whatever shape, but it's a frustum of a cone. The base radius is small r. The top radius is capital R. The height of this frustum is H. We are very specific on that. The height of this frustum is H. And the slanting length of this frustum is L. L. In this case, we will look into simple formulas. In this case, are you getting me by show of hands? I think there's a problem with the internet. Just me see by show of hands, 1, 2. 1 or 2 of you. Just by show of hands, if you're getting me. Thank you. Thank you. All right. So it's clear. Thank you. Okay, can continue. And I hope you have drawn it. Now, you know, there is a reason why in KCSE, we can no longer ask a basic question. We cannot ask you that, A, get the volume, 5 marks. Get the surface area, 5 marks. Never. Because there are now available methods that you can directly apply to get the volume of this. For example, the volume of this frustum is a third pi H. H is the height of this frustum. H is the height of this frustum. You multiply by capital R squared plus capital R small r plus small r squared. You direct and you have the volume. Direct and you have the volume. The only thing is the pi you are using here must be the pi you have been given. If you are told take pi to be 3.142, put it there. Take pi to be 22/7, put it there. Give your answer in terms of pi. Just use the way it is without putting any figure to it. But this formula will give you directly the volume without having to extend it getting the volume of the whole thing minus the volume of the small one which was cut. So you can easily get the volume directly. Are we together on that? By show of hands. You are okay? Can I listen to Mikotek? Unmute and ask. Okay, we can continue. We can continue. Thank you. So that is the formula for volume. Okay. What about the curved surface area of this bucket? The curved. Without adding the base, without adding the top. Just the curved surface area. Simple. Curved surface area is pi L. Pi L. Pi times the slant length. Pi times the slant length. Pi times the slant length of this shape. Then you multiply by the sum of the radii. Just that. You multiply by the sum of the radii. You will already have obtained the curved surface area. These are simplified formulas acceptable even by the National Exams Council because they are not drawn from nowhere. They are developed from the original methods until we get these formulas. So when we apply these formulas, we can get the curved surface area, and therefore we can easily do it. But remember, KCSE questions will always go to the application bit. The first bit you could be asked, get the surface, get the volume of the bucket. All right, then you say, the volume is simple. We are told this is the formula. You get quickly. You get your 4 marks or 3 marks. The second part, the bucket is filled with water to a given height. Calculate the radius of water in the bucket. Now you must apply similarity. Calculate the surface area of the bucket in contact with the water. Now you are applying the formula. So you can see the question can be broken down to application, but the formula are very, very important. Measurement. Number 3, statistics 1. Statistics 1. Number 3, I said there are 7. Number 3, statistics 1. Please, we will look into KCSE 2014. Then we look into the last 5 years. Why? KCSE 2014 is talking about construction of a frequency distribution table. That is, when you're given raw data, you are asked to construct a frequency distribution table beginning with a given value and maintaining a given interval. Then from there, we go ahead, we can get the mean, we can get the median, we can state the model class, class, and so on and so forth. But again, with that data, we can go ahead and we can draw histogram, and also we can draw a frequency polygon. So those are the components of statistics 1 that you must understand. But the current trends now involve application or use of histogram in finding median. Use of histogram in finding median. And the base here is a median line divides a histogram into 2 equal areas. So you look for a vertical line that can divide your median into 2 equal areas. The areas of the rectangles on the left must be equal to the area of the rectangles on the right. Number 4, we talk about transformation. Transformation 1. Allow me to take a bit of time on transformation 1. Allow me to take a bit of time on transformation 1. When we talk about transformation 1, we are referring to 3 elements. We want to look into reflection. We want to look into rotation. We want to look into enlargement. And these areas, sometimes we may go into translation, but translation will put it under vectors. These areas we are looking into, reflection. Can you reflect an object on a given line? That's the first question. Can you reflect an object on a given line? Another question, can you describe a reflection? How do you describe a reflection? By saying reflection in the line, then you state the equation of the line. When it comes to rotation, we are asking you, when you're given an object and its image under rotation, can you draw them? And after drawing them, are you able to locate the center of rotation? And also, are you able to state the angle of rotation? If the angle is clockwise, rotation is negative. If the angle is anti-clockwise, the rotation is negative. I mean, if the angle is anti-clockwise, rotation is positive. If the angle is clockwise, the rotation is negative. So you have to look into those ones under rotation. Enlargement. Enlargement. As a candidate, can you enlarge an object, negative scale factor and positive scale factor? In positive scale factor, it means that both the object and the image are formed on the same side as the center. In negative scale factor, it means the object falls on the opposite side as the center. So can you describe an enlargement? Enlargement, center, scale factor. Whenever you're describing enlargement, you must mention those components. It's enlargement, center, you state, and scale factor, you also state. And for your information, I believe the organizer of the meeting will maintain a platform. Don't get out of that platform, because before the end of the week, I will send you a manual that will guide you into term 3 as you prepare for the Form 1. All these things we have discussed, plus examples and assignments, will be in that document. Your work will just be to print it, and then you work them out. So that is about transformation. What you must know about transformation is this. 1, when you're drawing an object and the images, all the drawings use continuous line. Sometimes we see candidates with tendency of drawing the images using broken lines. That is illegal. All the objects and the images, draw them using continuous line. 2, label the vertices appropriately. If you're told, draw the square ABCD and its image, A prime, B prime, C prime, D prime, please ensure that the vertices of that object and even the image are correctly labeled. 3, where you are asked to state the vertices of a figure, you can state it on the space provided or on the diagram, but I advise that you state it on the diagram. For example, if this one is the grid in which you have drawn triangle ABC, and you're asked to state the coordinates of A, B, and C, you can state on the diagram. A, for example, is 1, 4. B, for example, is 5, 4. C, for example, is 3, 8. You state it on the diagram. So you state the object, the vertices, and the vertices, I mean the coordinates of the vertices also, you state there clearly on it. That is about transformation. Number 5, linear motion. I said there are 7. Linear motion. Linear motion. Under linear motion, I expect you to work on velocity time graph, interpretation of velocity time graph. Also, you look at the relative speed application. Relative speed application. Those are the 2 components of linear motion that we focus into when preparing for KCSE. Number six, we talk about vectors. Vectors one. Oh, vectors one. Components are 5. What are these components which are 5? The components are position and column vectors. Position and column vectors. That is, I am expecting you to know, position vector is with respect to the origin. If you are told the position vector of X is OX, given as maybe 2I plus 3J, then definitely X is a point 2, 3. Because this is position vector with respect to the origin O. When you're given OX and you're given OY also, you can get the column vector XY, which is OY minus OX, so on and so forth. So you must learn the position and column vectors. From there, you have to understand the magnitude of a vector, midpoint of a vector, translation of a vector, and collinearity or parallel vectors. And I'm giving you a comprehensive assignment on those areas where a question can combine 1, 2, 3, 4, 5, or even all the 5 areas put in one question for 10 marks. Very easy area also for 1. Once you know what it requires, you can score. Then the last part of Form 2 is, number 7, is quadratic equations, which is basically application of quadratic equations. Applications of quadratic equations, forming and solving quadratic equations. What is important here? We are focusing on the method you are applying, the method you are using to solve the quadratic equation. Another thing we are looking into here is your ability to discriminate the answer. For example, you're looking for the number of chairs. Number of chairs are -20 and +25. Of course, you will ignore -20 because the chairs cannot be negative. So that's called discrimination. So solving, forming and solving, and then discriminating, where you are applying the knowledge of understand, that you understand the whole concept of solving quadratic equations involving word problems. So that is it. Allow me to quickly brush onto the key areas of Form 3 and Form 4 work as we conclude our talk. Key areas of Form 3 and Form 4 work as we conclude our talk. We are concluding our talk in the next 10 minutes. Then allow me, therefore, to mention the key areas of Form 3 and Form 4 work in paper 1. One is sine and cosine rule. Sine and cosine rule. Wow. Pay attention to last instruction. For example, find correct to 2 decimal places, part A, part B, part C, which means the final answers in all those parts will be to 2 decimal places. Sine and cosine rule. Another point to pay attention to this. Pay attention to angles that are greater than 90. We call them obtuse angles. If theta is more than 90, you are calculating. For example, For example, you are given the length, for example, you are told this is 21 centimeters. This is 15 centimeters. This is 12 centimeters. One thing you must know, that if we have got such a triangle, then the longest side, unless it is a right angle triangle. If you are trying to apply 12 squared, if you are trying 12 squared plus 15 squared, you are getting 369, which is less than 441, the square of 21. It means that this angle is obtuse. But with the three figures, you can get the area. So the first question could be, hey, get the area of this figure. Then you say, using Hero's formula, and you apply Hero's formula very quickly. You say the perimeter in fulani, half of it, then the square root of s into s minus a times s minus b times s minus c. You get your answer, 2 marks or 3 marks. Part B, find the size of angle theta on angle CAB correct to 2 decimal places. Oh, then you say, but again, I was taught that half times 12 times 15 times sine theta should give me the area which I have already obtained in part A, which is still correct. But now that theta you are going to get will be acute. Remember, sine theta can be positive in the first or in the second quadrant. So based on the diagram that we have, remember that theta is obtuse, and therefore the right answer will be 180 minus the acute angle you have here. Or you can apply the cosine rule. 21 squared is equal to 12 squared plus 15 squared minus 2 by 12 by 15 by cos theta. And that will give you the angle directly. It will give you the angle directly without any stress. So you have to pay attention whenever you come to cos and sine rule, you have to pay attention to those two details. Number two is matrix application. That is forming linear equations in two unknowns and using matrix method to solve them. If, for example, you are solving for x and y, and you find the final answer, xy is equal to 1,200, 800. This is not the final stage. The final stage means go and say therefore x is equal to, or y is equal to. This one could be A1, but having this one could be the B1. In other words, you must show that now you have found x. Here, you have not found x. This is a matrix, this is a matrix. This is an equal matrix. But here, you have now found what x is, what y is. You must come down and say what x is and what y is. What is important in the matrix application, do not try that you are using maybe another method, like you are using elimination method, you're getting x and y, then you've conned your way out. No, you will be found. The best way is understand that whenever you're solving a matrix equation, pre-multiply both sides by the inverse of the matrix. After pre-multiplication, the left side will be reduced to basically identity matrix 1001 times xy is equal to the inverse times the constants, not the other way around. Pre-multiply, which means the inverse comes first, then the other matrix follows. Very, very important there. Number three is area form for now. Estimation of area using trapezium rule, mid-ordinate rule, and by integration. Very important part, and I will take some last 5 minutes or 2 minutes to clarify something in area. So area is important from power calculus. We also look into maxima and minima, plus application of maximum and minimum. Maximum and minimum. We also look at the application of it. Word problems. Word problems leading to maxima and minima. Word problems leading to maxima and minima. For example, if I tell you that an open cylinder has got a surface area of 600 pi square centimeters. Open cylinder has got total surface area of 600 pi. Where is that 600 pi coming from? It is coming from the area of the base plus the curved surface area, which is 2 pi r h. Why 2 pi r? Circumference times the height. It's coming from that. So this one is equal to 600 pi. You can clearly see pi can go, pi can go, pi can go. R squared is plus 2 RH is equal to 600. You can find an expression for H alone in terms of R. You can find an expression for volume in terms of R only. You can find the value of R for which the volume is a maximum. You can find the value of H for which the volume is a maximum. You can find that maximum volume. That is application of maxima and minima. After that, we look into kinematics. Kinematics, mathematics of motion. A function, V function, S function. We have to look into those cases, that is application of calculus in kinematics. We have 5 minutes. Allow me to say something on area, and then we conclude our talk. But remember, I've told you, don't get out of that wall that has been formed by the organizers of this good meeting, because when I find my time before Monday, of course, I am going to post a manual for your preparation in this wall. Your work will be to print that manual and follow through what we have discussed, do the assignments and the examples which are there, and you follow them. Allow me to talk about the area a little. A case in hand, and I believe I can pick it from a KCC. I want to use it as an example a little, and then we call it a day. Then we call it a day, after which we call it a day. Very good. Hope you're able to see this. This was KCSE 2022. Curve. Y is equal to 2x squared plus 1. There's another curve. Y is equal to x squared plus 1. It moved up to 5 from 0. Now, you'll see it in KCSE 2021. And listen how easy the equation of area can be set for you. The diagram below is a sketch of two curves. Y is equal to 2x squared plus 1 and y is equal to x squared plus 1, drawn on the same grade. Using the mid-ordinate rule with 5 strips, estimate the area bounded by the curves, the two of them, and the given lines, 5 marks. Another method was trapezium rule, 5 marks. 5, trapezium rule, mid-ordinate rule. You are supposed to apply those methods to get the area that is bounded between these two curves. Oh man, 5 marks, 5 marks, so easy. So easy. Many candidates were applying those formulas, getting the whole area, subtracting from the other one. Headache. When it's supposed to be very simple. First of all, I expect the candidates to get the equation defining the region. The equation defining the region is the upper curve minus the lower curve. If you subtract the lower curve from the upper curve, you will find 2x squared plus 1, if you subtract x squared plus 1, look here. 2x squared plus 1, if you subtract x squared plus 1, you are getting 2x squared minus x squared, which is x squared. 1 minus 1 is 0. So that is the equation defining the required area. So this region is y is equal to x squared. That is the region, the upper minus the lower. We expected the candidates to start by saying upper minus the lower to define the region. Wow. Once that one is done, the whole equation can be sorted out. If you are supposed to use trapezium rule and 5 strips from 0 to 5, then x would be 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 ordinates. But strips are 5. Between 0 and 1, 2, 3, 4, and 5. Now, our y will be the new y, which is defining the region, x squared. So I'm expecting 0, 1, 4, 9, 16, and 25. Then the area now becomes a half times height into the sum of the ends, which is 0 and 25, plus twice the sum of the remaining ordinates, which is 1 and 4 and 9 and 16, close. And you have your answer. You get 5 marks simply having the table, this expression, and your answer. You have 5 marks. So you can see how easy it can be when you know the equation defining the region. When the candidates were asked to get the same area using mid-ordinate rule, and now using 5 strips, it means we have to create a new table. Let me wrap this. Create a new table. Mid-ordinates, we are picking from 0 and 1, that is 0.5. From 1 and 2, 1.5, 2.5, 3.5, and 4.5. 1, 2, 3, 4, 5 of them. We are picking the mid-ordinates between 0 and 5. So what was the expectation? The expectation now here is get the corresponding values of y for which the function is y is equal to x squared. Where is x squared coming from? The difference between the upper and the lower. So we get 0.25, 1.5 squared, 2.25, 6.25. This should be 12.25. This should be 20.25. And the method is simple. That area is equal to the width, which is 1, times the sum of the mid-ordinates. 0.25 plus 2.25 plus 6.25 plus 12.25 plus 20.25 close. And you get the answer. Allow us to conclude our meeting today. It is 1:30. By saying, when you are preparing for paper 1, ensure that you are well conversant with the topic areas we have discussed. Somebody may ask, but sir, we are taught in Form 1 divisibility test. Where is it applied? No. When you're handling indices, you are doing some factorization, you are applying the knowledge of division. So those are some of the issues that you are taught in Form 1 and Form 2, and you're supposed to apply them across the syllabus. Remember, the skills that you must have are evaluation skills, that is computation skills. You must also have construction skills, accurately able to construct. You must be able to construct. And then you must also have the graphical skills, drawing your curves in the way in which they are required, or figures in which they are, the way in which they are required. So those are the items of focus when it comes to mathematics paper 1. Thank you so much. Until next time. Any question? Any question? Yes, Otieno Martin? Unmute and ask.
Hello.
Yes?
So I had a problem back behind there. There was a formula that raised up my hand and I could not see a response to me.
Which
So
formula?
about the complementary angles.
Mm-hmm.
So there at the linear equation, you drew something like -2 greater or equal to x less, no, yes, less or equal to x and less to 3. So there should be a line to be drawn there to show the direction.
The number line.
Yes.
It was something like that.
Yes, that one.
And I said the number line must be straight.
Uh-huh.
I said it must have arrows on both ends.
Yes.
And I said when you are dividing it, the intervals must be equal and carrying all these values. For example, -3, -2, -1, 0, 1, 2, 3, 4, and so on.
Yes.
The values in your inequality must all be, you must be able to fit them in the number line. So when you're beginning with -2, we said you start with -2 and you shade. You know why you shade it?
To show the where you begin.
Yes, because -2 is part of x. X can be, -2 is less than, but can also be equal to x. So we shade it.
Yes.
Right?
Yes.
Then 3 is just circled but not shaded because x does not reach 3. It is less than 3. So.
Yeah.
Then
Yes.
after you take your ruler and you can make the line segment between -2 and 3 bold. This one you do. Why I encourage that you do it, even if you don't do it, the answer will still be accurate because you can see the starting and the ending point. But we encourage it because look at a case where you are asked to represent x is greater than or equal to 5. Just that, express it on a number line. Just that. It means if this is a number line, 1, 2, 3, 4, 5, 6, 7. X is greater than or equal to 5. It means from 5 onwards. If I don't make the line bold on the left or on the right, I will not know where the value is moving to. That is why I will now make the part on this side that it can be 5, 6, the integral values, 7, and so on. So I make it bold coming to this side. Are we together?
Lower your camera a bit, please.
That way?
Yes, yes, thank you.
Now you can see it. You can see now why I need to make it bold. Eh?
Yes.
Because now I can see x can be 5 onwards. If I don't make it bold, I may not know which side from 5. Are we going to the right or to the left? Sawa?
Yes, sir.
Okay, thank you. I think we'll take about 20 minutes. Suraro, 20 minutes. At 2. Yes, our facilitator for paper 2 is already here. And we are beginning paper 2 at exactly 2 p.m. So we'll take some 20 minutes break or so, get your lunch, refresh a little, prepare, and come back at 2 for paper 2. Thank you so much, and God bless you. Wow. Mr. Rao, now I am ready to go for another talk in Chogoria. Chogoria in Meru. I want to move straight away, talk to those girls. And, I think I can reach there at night. Then tomorrow I come back. Yes. You talk to them. You can go and research the property.
Ah, 20 minutes break. I'm ending the meeting. So kindly join by what time? Join by 1:55. So have a 20 minutes break. Jason, you have a question? Yes, you can ask.
Meeting ID. Can I get the meeting ID, please?
We are using the same link, what you've used to join.
Okay.
Okay. We are using the same link.
Thank you.